All right, this is a second video for the formative review. This one's going to cover solving, specifically indicator 5.3, which are your specialty equations. So we're going to be looking at question 3, question 4, and probably question number 5, unless the video gets super long. All right, so question number 3, we have 9 raised to some power equals 27 raised to some power, and I want to solve this. So I want to try to get 9 and 27 to be the same base. Now, normally what I would try and do is make the 27 turn into a base 9. I can't do that. But I can make both of these turn into base 3s. So as a gentle reminder, 3 squared would be 9, and 3 to the third is 27. So I can replace both of these. So that's what I'm going to do. So 9 is going to get replaced with 3 squared. Keep the original exponent of 4 to the x minus 2. And then 27 is going to get replaced with 3 to the third. Again, keep the original exponent, 5 to the x plus 6. All right, exponent rules kick in here. So we have a power raised to a power. You get to multiply. So we're going to do 2 times 4x, so 8x, and 2 times 2 is going to be minus 4. Do the same power rule on the other side. So 3 raised to the 15x plus, what would that be, 18? Yeah, sure. Okay. So now I have the like base and a like base. Love that, because I can make those exponents equal. All right, so bases no longer matter. 8x minus 4 equals 15x plus 18. Whoops, not just 8, make it an 18. See, these cause problems. All right, so we have a linear equation here. I want all the x's on one side. I want the numbers on the other side. So I'm going to go ahead and subtract 8x. At the exact same time, I'm going to go ahead and subtract an 18. That will get my x's to the right side, my numbers to the left side. Okay, because again, if you see this, right, notice that nothing is like double stacked. They're not interfering with each other. So 8x minus 8x, bye-bye. Negative 4 minus 18 should be negative 22. Let's see, 15x minus 8x would be 7x. 18 minus 18, gone. To finish it out, we're going to go ahead and divide both sides by 7. I'm going to put this off to the side here because I write huge. 22 over 7. It is negative. Cannot be reduced, cannot be simplified. So that should be your answer for question number 3. All right, sliding right along to question number 4. I did mark this one with an asterisk because, well, you're going to need a calculator. All right. Unlike the last question where I could turn a base to be the same bases, I can't make a 127 turn into a base 7. So let's go ahead and take the log of both sides. So log of 7 to the x equals log 127. One of our properties of logarithms takes this exponent and flies it in front as a coefficient, which is hugely powerful in changing an exponential situation into a multiplication problem. Folks, I know we can solve multiplication problems because we know how to divide, all right? Or we know how to tell our calculator to divide. Speaking of calculators, let me go grab mine. All right, split screen, it resized, so there we go. All right, so log of 127, close the parentheses, then divide by log 7. Please, please, please make sure you close the parentheses. Okay, I believe my answer is going to be 2.4, rounded up is going to be 9. But always I'm going to double check this. So go back to the original, 7 to the x, where x is this 2.48 blah, blah, blah answer. And I want to make sure that turns into 127. So 7, raise it to the last answer. Yep, that's 127. There is guarantee then, as long as I didn't screw up my rounding, that is what x is equal to. All right, so there's number 4, part A. Zooming right on over to part B. Let's see here. We've got a logarithmic equation that I'm going to turn into a exponential equation. So we've got 4 squared equals the argument of x minus 2. So let's see. 4 squared is 16. That equals x minus 2. To solve this, let's go ahead and add 2 to both sides. So 16 plus 2 is 18. Quick double check. Make sure that this value for x keeps this whole argument positive. So yeah, 18 minus 2 is absolutely a positive value. So that is the correct answer for part B. All right, so that's number 4 done. Number 5 is a little bit of a word problem here. All right, so the height, h in feet of a particle above the ground at time t seconds is given by this equation. All right, and we've got a bunch of information that we want here. So what is the greatest height? What is the particle's height at 3 seconds? And when is the particle at its greatest height? So question A and question A and question C are both related to greatest height. Question A is what is the greatest height? Question C is when is the particle, so what time? So basically what I want to find here is the vertex. I want to find the vertex of this graph. So I'm going to do x is equal to the opposite of b over 2a. So b is 64, the opposite would be negative 64. A is negative 16. So negative 64 over negative 32. I believe that's just 2. I am going to double check that math just to make sure that I didn't do something dopey and then, base my next answers off. It is 2. Okay. Let's get rid of the calculator. I will need it back in a moment, but that's okay. So here's the thing. As far as my vertex goes, okay, and actually let me write vertex here, just so you know what I'm talking about. We have 2, right? Our x value is 2. Now I want to find the y value, or the h of t value. So we're going to do h of 2, and everywhere I have a t, I'm going to replace it with a 2. Actually, I should change that because this equation was not written in terms of x's, it was written in terms of t. All right, so just a quick fix on that part. It doesn't change the values that I used. So negative 16, t squared is going to be 2 squared, plus 64 times 2 plus 160. Okay, so this, I'm going to throw into a whole calculator here. I should say I'm going to throw the whole thing into a calculator as opposed to throwing into a whole calculator. Okay. So here's the thing. With the TI, I can literally type this whole thing in at once. I don't need to do it in parts. So negative 16, 2 squared, plus 64 times 2, plus 160. Quick double check. Yep, I'm getting 224. So 224. So this equals 224. So my vertex is 2, 224. And what this means in terms of our question is this part is time. This is our t value. And this is your height. And so what this tells me is this is actually the answers to both question part A and part C. So if I kind of zoom out here, get all the bits parsed. Okay, there we go. So what is the greatest height? What am I talking about? What is the greatest height attained by the particle? Oh, all right. Let me kind of shrink that down and slide it over. All right, what is the greatest height? And that is going to be 224. This is in feet, so feet. All right, and when is the particle at its greatest height? And that is a time of 2 seconds, because time is in seconds for this question. All right, and next part here for part B is what is the particle's height at 3 seconds? So I'm going to take this equation and I'm going to figure out h of 3. All right, so separate little piece here. This time I want to do h of 3 because I'm figuring out what's our height when time is 3. So all the little t's for time, I'm going to replace with 3. Right, and I'm just rewriting it here, and I will use the calculator because, well, that's definitely a calculator question. Now, in theory, you could do the parts of this, figure out, 3 squared is 9, take that times negative 16. But if I have a calculator, I want that calculator to do as much for me as I will let it, and I will let it do a lot. 208. All right, so this equals 208. So what is the particle's height at 3 seconds? 208 feet. Now, in a question like this where all the little answers here are all bunched up, please make sure that I can clearly see which answers go with which part. On the format, I'll try to make sure there's a little bit more space there to give you, well, space to work, but also space to make sense of the answers. All right, so that's the bits, parts, and pieces for solving indicator 5.3. That was question 3, question 4, and question 5. And come back if you need any help on the next video for section 7.2. As always, let me know if you have any questions and or concerns.